Oh, I think my cold is getting better, or my allergies, whatever.
Good. Oh man. Yeah, it's been killing me, I know that.
Yeah,
But yeah. Alright, cool.
okay, so I got this page.
Oh, yeah.
Here is a theorem that says if you put out a line that bisects this angle,
Mm-hmm.
which this vertical line does,
Right.
then the ratio of these two sides,
Uh-huh.
these two segments, is in the same ratio as these two segments.
That makes sense. So would it be 9m is equal to 20 plus 12?
Well, no, it's a
Or
ratio. So 9 over
over n. Okay.
equals,
Is equal to 12 over 20.
right. And make sure you put um, these together. In other
Okay.
words, that's the same ratio, incidentally, as 9 over 12 equals m over 20.
Mm-hmm.
Well, huh.
Yeah.
Whether they intentionally meant to put an m there, or that means meters. I bet that's a variable.
Yeah, probably.
But in other words, notice that this gives you the same thing. A
Mm-hmm.
lot of these ratios, you can frequently do that. In other words, I can relate this segment to this segment, making it equal to this segment over that segment. But I
Right.
can also relate this number to this number is the same as that number to that number. And
Okay.
notice why you can do that. If I cross multiply, I get 20 times 9 equals 12m.
Uh-huh.
Well, down here, if I cross multiply, I get 12m equals 20 times 9.
Okay.
So it results in the same formula regardless of how you put it together.
Mm-hmm.
This might be the preferred way, I suppose. If for, for no other reason than the variable is in the numerator.
Mm-hmm.
I know m has to be 15.
Mm-hmm.
If I solve this equation, I get m equals 15. And
Okay.
what are the units on it?
Centimeters,
Uh,
right? Oh.
oh, yeah,
Oh. They're different.
they are.
Yeah.
M has to be 15 centimeters.
Yeah.
In other words, if I use this first one,
Uh-huh.
I get 9 centimeters over m meters, or centimeters, because
Yeah.
this one is meters over meters. So this
Mm-hmm.
one has to be centimeters over centimeters.
Mm-hmm.
And so the answer is in centimeters, yeah.
Cool. Awesome.
Let's look at number 2.
Cool. Would you just do 18 over n is equal to 4 over 6?
Yeah, that's a true relationship. Why is that true?
Because it shows that the two lines are equal to each other.
No, because they're similar triangles.
Similar triangles.
Yeah, in
Okay.
other words, one of the triangles is the top one,
Mm-hmm.
and the other triangle is this one.
Mm-hmm.
And they're similar because these two lines are parallel.
Yeah.
The fact that they're parallel makes that angle equal to that angle,
Mm-hmm.
and this angle equal to this angle, which means this angle is equal to itself.
Mm-hmm.
So you have three angles that are equal to one another. That
Okay.
the two triangles similar, the big one and the little one,
Mm-hmm.
and similar triangles have a property that their corresponding sides are proportional. So
Okay.
18 inches over n inches
Mm-hmm. Yeah.
equals 4, uh, hold on a minute.
Okay.
It's actually equal to 4 plus 18 over n plus 6. And I'm not 100% sure that that is the same as 4 over 6. I don't think it is.
Yeah.
I'm not sure if you can say 18 is to n as 4 is to 6.
Right.
I don't think you can. No, the only thing I can say about these two things is this triangle is similar to this triangle. So if I'm going to compare this side to its right side, in other words 18 over n, then I have to compare this whole side to its right side. And this whole side is 22. And this whole side is n plus 6.
Right.
Let's just do the math on that.
Okay.
Yeah, and then they're going to ask us for O. And O is going to share the same relationship. Whatever this ratio ends up being, the ratio of O to 30 will be the same. Hold on. Let's do the math on this. Just if you know the reason, satisfy my curiosity.
Yeah.
Hold on. I didn't mean to do that.
You're good.
So what do I have? I have 18 times n plus 6 equals 22 times n. So that's 18n plus 108 equals 22n. So 4n equals 108. N equals 27.
That makes sense.
Okay. So now I can say, since n is equal to 27, so my picture is clear now. In other words, if n is 27, this whole side is 33.
Right.
This is, O is what we're trying to solve for. This is 30. So I can say a number of things. I can say 18 is to O as what?
So, let me see here. Yeah, so 18 is to O as 4 is to 30.
No, make sure you compare the same things. In other words, if I'm comparing 18 to O, I'm comparing the left side of that triangle to its base.
Right.
Now
so it would be 27 over 30.
Well, how about 22 over 30? You got to compare the left side.
Right.
That's 22 over 30, and then you can solve for O. Easy enough.
Okay, that makes sense.
But let's see what happens if we did it the way you suggested. I don't think it's going to give us the correct answer. If I said 18 is to n as 4 is to 6, no, it does give us the correct answer. 108. I still get n equals 27.
Okay.
So that is legitimate to do what you suggested. The fact that these are both parallel means that it splits these two sides into proportional sides. Even though this is actually a trapezoid now, it's no longer a triangle. Fact is that that to that is the same as that to that. So it was really easier the way you first tried to do it. Got confused. I wasn't certain of it.
Oh, it's all good.
All right, so let's see. Problem number 3 here. Cool. And what they tell us is that this figure is similar to this figure.
Right.
So, is it aligned properly?
It is, yeah.
Yeah, it is. So what's angle A?
So angle A is 161.
Okay, go ahead and write that in there, because you need that.
Sure. Definitely.
What's angle Y?
Angle Y is, where is angle Y? Oh, there's angle Y, 112.
Correct. And angle D.
Angle D is 135, or 133. Yeah, it's just 133.
33. Okay. And now we have to find, in order to find these segment lengths,
Uh-huh.
we have to find corresponding side. Well, the corresponding side that, that we have both of is 15 and 9.
Uh-huh.
So all my calculations are going to be based on that ratio. 15
15
is to 9 as BC is to what?
So it'd be 15 and 9 is equal to BC over, where's BC? 21?
Correct.
Cool.
Now, let's just look at that for a moment.
Yeah.
This is another case where we have the variable in the numerator.
Mm-hmm.
What's the first step in solving that right there?
You cross multiply?
No. That's what
No.
everybody wants to do, but notice that it requires a second step if you cross multiply. You do 29 times 15 equals 9 times BC. Now I got to divide both sides by 9. Well, I just multiplied both sides by 9.
Right.
Doing an extra step that's not necessary. What if
Okay.
you just multiply both sides by 21?
Okay. Makes sense.
And that's only one step. Now,
Okay.
I have to turn that into a number by either simplifying or I can do various things. But I have to turn it into a number, but it's the same numbers I would have gotten if I'd have cross-multiplied, only I would have had to do 2 steps to get to the So always remember, just because you can cross-multiply doesn't mean you should.
Okay. That makes sense.
CD. How can I solve for CD?
So CD, let me see here. So we could do, 7.5. How could we do this?
Start with the known ratio.
7.5.
No, 15 is to 9. In other words, there's only one side. There's only one side that we have both measurements, and that's this side right here.
Right.
Every other side, we only have one or the other.
Okay.
So this is our ratio, 15 to 9. That is the similarity ratio.
Right.
You can't really, but you can think of it as this this object is 15 ninths the size of this. But that's not really true. The area is not, because the area we know is squares. But every side in this polygon is 15 ninths of the distance over here.
Makes sense.
Okay, so 15 over 9, I'm trying to solve for CD.
Right.
What goes on the other side of that equation?
15 over 9 is equal to 7.5 over CD.
Make sure you get it in the right.
Or CD over 15.5.
Big over little has to be the same. You can't reverse it.
Right.
CD
over 7.5.
Big over 7.5, yeah. And then, again, our variable's in the numerator, so all we have to do is multiply both sides by 7.5. We don't have to cross-multiply.
Okay.
WV.
Alright. So to find... So with WX, like the last CD, like the last one we just did, it'd be 7.5 is equal to 21 times...
No, don't start. The secret to all of these is to always start in the same spot.
Okay.
Well, what spot have we been starting every problem so far?
15 over 9.
15 is to 9.
Right.
That's the ratio that every side over here is going to be to this side. So now, what goes next? And we're trying to solve for WV, this side.
Oh, yeah, my bad.
So what goes on the side of the equation?
is equal to, so it'd be 15 over 9 is equal to, we're trying to solve for WV. Where is that? Oh, there we go. So it'd be 20, or or WV over 20.
No.
Or it's because it's big over.
Yeah, if I do this,
It's
I got
wrong.
little over
right.
big.
Right.
Big over little, and it's going to make a big difference. You're going to get the wrong answer if you switch them up.
Right.
Okay, so it's got to be big. The big side is 20. The unknown side, the little side, is that. Now notice that we do have to cross multiply.
Right.
Because my unknown is in the denominator. So to get it in the numerator, I got to do this. Now divide both sides by 15. And I get 12 for an answer.
Yeah. That's
and finally, WX.
Alright. There we go. So we could, 15 over 9 is equal to, 35 over WX.
Now you got it.
Cool.
Alright.
Alright.
Go to the next one. These are long problems, but maybe not as long as I think.
Yeah.
What ratio do we know?
Let's see here.
They're all parallel. In other words, P is parallel to Q is parallel to R is parallel to S. So this is going to be very similar to this problem up here on the right. Okay, you've got a triangle that's being cut by all these parallel lines. So we already figured out that 18 is to n as 4 is to 6. That's a true statement.
Yeah.
Well, what can we say here?
We can say that, well, 12 over 21 is a good start, right?
Let's just be consistent.
Okay.
12 is to v as what?
So 12
sides that are both numbers.
Okay, is equal to 28 over 35.
Yeah, there you go.
Cool.
And now you can solve for v. And that same rate, and once you solve for, actually I don't need that ratio. I can use this ratio, 28 over 35, which happens to be 4/5. It's really 4 over 5. And let's answer the rest of the problems. So 4 over 5 is our ratio.
Okay.
This left side to the right side. So how do I get W?
So we would do 4 over 5 is equal to W over 35. Or 35 over W, my bad.
No.
Or no, that's not.
The 4 over 5, let me go back and change that because it's confusing once I turned it into once I simplified the fraction.
No, it's alright.
There's the ratio. The left side to the right side
is equal to 12 over V.
Correct, but we've solved for V already. We're trying to solve for W.
Okay. So to solve for W, you would do 21 over W.
Left side over right side.
So
that 21 is a base. So far we have not looked at any base.
Right. So it'd be 8 over W then?
Yeah.
Okay.
In other words, you have to be consistent in your corresponding parts.
Right.
If I'm comparing this, the left to the right, it's the left to the right, or the left to the right, or the left to the right. None of those use the number 21. We will, once we start trying to solve for y and x, we'll use 21.
Right.
But for all of these side dimensions, we won't.
Okay.
So again, on that one, you're going to have to cross multiply. And about x.
So x, let me see here. Okay. So we would start out with 28 over 35
Okay.
is equal to 20 over x.
Yeah.
There we go.
And now solve for y. Now, this triangle is similar to this triangle.
Right. So y, okay. So it would be, how could we do
And
this?
remember, you can do this in a number of ways. You could say 12 is to v
As
21 is to y,
right.
and we know what
That
v is. In other words, we
right.
solved for v.
Yeah.
But the way I actually prefer to do this is, let's look at this triangle. That side is to the base, and you can do either way. It just depends on how you choose to look at it.
Yeah, that's what I was going to do. I was going to do 12 over 21 is equal to 8 over y.
Not 8 over y.
It's not 8 over y.
No, these are similar
Oh, it's
triangles.
28 over y.
20 over y.
Yeah.
In other words, what I did is I took the left side of that triangle over the base. That has to be the same ratio as the left side of that triangle, which is 20, over its base.
Okay.
Okay?
Okay.
Now, how do we solve for z? That's the last thing we haven't solved for you.
Right. So to solve for z, we could do 28 over 35 is, actually no, because it's no.
Yeah, I'm not positive that's true. Let's use this
Yeah.
same thing. In other words, z is the base of the big triangle.
Right.
And the big triangle is similar to this tiny triangle.
Mm-hmm.
So let's still go with 12 over 21
Okay.
equals what over z?
So, 12 over 21 is equal to 28 or 35 over z.
Well, it's the sum of these distances. That whole left side over z is what we want. Well, that
Okay, so
left side is 12 plus 8 plus 28 plus 20. That's
right.
20, 20, and 28. That's 68.
Yep. That makes sense. So 12z is equal to...
You see that? In other words,
right.
what we're dealing with here is similar triangles. The top triangle looks like this. The big triangle looks like this.
Right.
We know they're similar because they have the same 3 angles.
Mm-hmm.
Well, if it's similar, then 12 is to 21 as A is to B.
Uh-huh. Yeah.
And A is 68.
Right. Cool.
All right.
Perfect.
There's some problems that don't start with a general equation, which is rare.
That is, yeah. Yeah.
Okay.
For number 1, you could just do
There's the cliff.
6 over 72 is equal to x over 10.
Well, I don't know yet. I gotta look at it. There's the man.
Mm-hmm.
There's the cliff.
Yeah.
The cliff is casting a shadow. In other words, the sun is up there. Mm-hmm. And so the cliff is casting a shadow that is 72 feet long. Mm-hmm. Eddie there's no way Eddie's casting a 10-foot long shadow.
Yeah.
See why?
Because he's standing
in the shadow of the cliff.
Right.
So
yeah, exactly.
You can see his shadow.
No.
This is kind of a crazy problem, but this is what we mean. He's 6 foot tall, and he's casting a 10-foot long shadow. Mm-hmm. So how tall is the cliff? Well, this shadow line is parallel to that shadow line, which makes this triangle similar to the big triangle.
Okay.
Once you discover they're similar, how can you solve for the height of the cliff?
Pythagorean Theorem?
No, similar triangles. This whole page is really about similar figures. If you look at every single problem, this is similar to this, that triangle is similar to the big triangle, all of these triangles are similar to each other. So let's work it as a similar triangle. Here's our two triangles. We got a big one that is 72 down here. Then we got a little one right there that is 10 foot there and 6 foot there.
Yeah.
So what's the relationship you can use?
So you can do...
I'm trying to solve for this. We'll call that y.
Okay.
It's the height of the, cliff.
Okay, so you can do 6 over x is equal to...
An x. I don't see an x.
I mean, yeah, 6 over y.
No?
No.
Well, you actually could do it that way. But pick two numbers in this triangle.
6 over 72.
How about 6 over 10? 72 isn't in that triangle. 72 is the measurement of the base of the big triangle.
Okay.
Okay?
So
6
over...
Yeah, I'm saying the right side over the base has to be the same ratio as what?
Y over 72.
Yeah. That's the most straightforward way to do it.
Yeah.
Is to relate two sides within the same triangle and then find the same two sides in the bigger triangle. Rather than trying to relate 10 is to 72 as y is to 6, but notice that's also true. 10 is to 72. I can relate the base of this triangle to the base of the big triangle.
Right.
It has to equal this side of the little triangle, which is 6, compared to that.
Right.
And now it appears we've done two completely separate things. But look at what happens if we try to solve that. Cross multiply, you get 10y equals 6 times 72, regardless of which one you use.
Yeah, exactly.
And that's always the way it is with these proportions. You have similar triangles. Let's just review that because this is not that clear to everybody.
Sure.
Let's review a 3, 4, 5 with a 6, 8, 10.
Okay.
We know they're similar, right?
Right. Yeah.
Well, I got all kinds of ratios I can set up here. I can say 3 is to 6 as 4 is to 8, as 5 is to 10. In other words, I can compare the left side of that triangle with the left side of that triangle and go from there.
Yeah.
But I can also say 3 is to 4 as 6 is to 8. In other words, I can compare the two sides within one triangle to the two sides in the other triangle. And it, again, produces that same phenomenon where when you cross multiply, you end up with the same thing regardless of which one you used.
Yeah.
Whether you use that one or that one. Sorry. Excuse me.
Oh, no, don't worry. I totally understand.
I am getting better. I do feel a little better than I did the other night.
Good. The allergies are the worst this year.
Well, I was convinced it was allergies, and then it started moving to my chest, and I started wondering if it wasn't a cold.
Yeah.
I'm getting better, and it hasn't really moved to my chest, so I don't think it was a cold. I hope it's not.
Yeah.
You know, that's
hopefully.
You don't want it to move to your chest, because then you start coughing, and you can get pneumonia and all kinds of stuff. So.
Oh, which is not good. Yeah.
As long as it just stays in my head, I'll take allergies.
For sure. Me too.
Dig this. Yeah. The diameter of a small drink is 2 inches, while the diameter of a large drink is 5 inches. if the cups are similar and the volume of the large drink is 75 pi, what's the volume of the small drink? Now,
Okay.
be a little careful here. Let's draw it so you
Sure.
can see what's going on.
Yeah.
It's not going to be what you think.
Okay.
Well, maybe it is. I shouldn't say that.
No, you're good.
So the diameter of that is 2, the diameter of that is 5, and they are similar.
Okay.
The volume of this large drink is 75 pi. Now, you have to kind of go back to the section in geometry where you were studying linear relationships, area relationships, and volume relationships.
Mm-hmm.
Let's talk about that for a moment.
Okay.
You might be inclined to say 2 is to 5 as the area of that is to the area of that, right?
Mm-hmm.
That's
Yeah.
not true.
No.
What's the area of this?
The area would be 1,936.
No, just the top.
Oh, just the top.
The area of that top.
Pi times radius squared.
Give it to me. What's the answer?
So it'd be just one. No.
Yes, just one.
Is that just yeah? Yeah.
Okay. What's the area of this?
2.5 pi
It's 2.5 squared pi.
or squared pi. Yeah.
That's 6.25 pi.
Cool.
Well, notice this is in a 2 to 5 relationship. This is in a 1 to 6.25 relationship.
Mm-hmm.
So the moment you go from a linear similar factor to an area, guess what? It's the square. In other words, it's 2 is to 5 as 4 is to 25.
Yeah.
This area relationship is 4 is to 25. That's the same as 1 is to 6.25.
Right.
Now, when you go to volume, you cube the linear relationship. So if I want the two volume relationships, it's going to be 8 over 125.
Okay.
In other words, it's 2 cubed over 5 cubed. So this is the volume of the 2-inch small drink. This is the volume of the 5-inch drink.
Yeah.
The 5-inch drink is more than 10 times. It's 15 times the volume of the 2-inch drink. And yet the radius is just barely double.
Yeah.
Okay? So if this is my volume relationship, and they're telling me that the volume of the big cup is 75 pi, that's the volume of the little cup.
That makes sense.
And you do just multiply both sides by 75 pi and solve for x.
Okay.
That's the key with these kind of problems is always, let me just give you a couple of others as practice here.
Sure.
If I have a square with a side of 2 and another square with a side of 6, what is the linear ratio? Always do big.
1 to 3.
Nah, always do big to little. I don't care what
3 to 1.
I don't care what your teacher says. Big to little works so much better than little to big.
Okay.
Notice that when you do little to big, you always have fractions.
Right.
When I do big to little, I may not have a fraction. It's 6 to 2, which is actually equal to 3.
Exactly. Yeah.
So what's the area ratio?
So the area ratio would be,
If the linear ratio is 3 to 1, what's the area?
so the area ratio. It would be
The square?
2 to,
It's the
2
square
to
of
1.
the linear ratio.
Oh, okay. So 9 to 2.
9 to 1.
Or 9 to 1, yeah.
Square top and bottom.
Okay.
Top squared is 9, bottom squared is 1.
Mm-hmm.
What's the volume ratio?
Then the volume ratio would be, what's 81 times 2?
Not 81. It's 3 cubed.
Oh,
In
3
other words,
cubed.
it's the cube of the linear ratio.
So 81 to 1.
Not 81. 3 cubed is 27.
I don't know what I was thinking there. Yeah, my bad.
So, and here's what we're talking about.
Yeah.
If I had a cube that each side was 2, well, clearly it has a volume of 8. If I have a cube over here that each side is 6, 6 times 6 times 6 is what? 216?
Yeah.
That volume is 216, and guess what? That's 27 times 8.
Yeah.
So this is a very, very key point in geometry, is when you can figure out a linear ratio, like we could on the soft drinks, the linear ratio was 5 to 2.
Yeah.
Then we know the volume ratio has to be 5 cubed over 2 cubed. In other words, if I make this a 5 instead of a 6, now the linear ratio is 5 to 2. It doesn't come down to, it's just 5 to 2.
Yeah.
What's the area ratio?
So if that's 5 to 2, then it would be 25 to 4.
And the volume ratio?
And then that would be 100 to
No,
8.
not 100.
Or 1.
What's
Or
5 cubed? Always go back to the linear. Don't try to do anything with this 25.
Yeah.
Go back to the linear. It's 5 cubed over 2 cubed.
Right.
So that's 125 over 8.
Yep.
All right. Now let's do problem 3, which is going to require this analysis.
Yeah.
They're similar cylinders. Surface area is the same as area. In other words, if we know the linear ratio, then the surface area ratio is going to be the square of the linear ratio.
Yeah.
Okay. So what's the linear ratio?
Okay. So the linear ratio would be
We can see.
21 to 8, or h over 21.
Good. Big to little. H over 21. That's the linear ratio. Now, they tell us that the volume ratio is this number to this number. Well, what is the volume ratio?
The volume ratio would be 2,662 pi over 686 pi.
Well, actually the volume ratio, doesn't it have to be h cubed over 21 cubed?
It could be like that, yeah.
Well, that's a good way to start it.
Yeah, for sure.
Now, I'm going to put the rest of the ratio. The volume ratio is also 2662 pi over 686 pi. Well, now I have something that I can solve for h.
Right.
It's not particularly easy. You're going to have to take the cube root. You can certainly cancel the pi's, multiply both sides by 21 cubed, and then take the cube root of whatever number that is, and that will give you h.
Okay.
Okay? Now, let's talk surface area. This is the linear ratio. What's the surface area ratio?
So the surface area ratio would be h over 21 is equal to 1936 pi.
Don't start there. Start with the principles that we've been talking about. When you go from linear to area, you square the numerator and the denominator. When you go from linear to volume, you cube them. So this is going from linear to area.
Okay.
So it's got to be h squared over 21 squared. Now that's equal to the surface area of the big one, 1936 pi, over the surface area of the small one. And notice we've solved for h. So I know what h squared is.
Yeah.
So this really only has one variable in it, and that's the surface area of the small.
Okay.
Okay? I recommend doing this technique for any type problem like that, is find your linear ratio to begin with.
Okay.
And square it to get your area ratio, and cube the linear ratio to get your volume ratio. And once you do that, you'll be able to develop these equations that you can solve. In other words, the very first thing I did was cube top and bottom. And I know what the volume ratio is. They give it to me. The volume ratio is this volume over this volume. No variables there.
Yeah.
That's the way to do that.
Cool.
You want to end it there?
Sure. That was our review for today, so I think that was a good session.
Well, it was. And we went over stuff that you haven't gone over in a while. In fact, I remember this was actually last semester's material. Because
I remember that, yeah.
Linear ratio, area ratio, and volume ratio were all, I was doing it with everybody preparing for last semester's final.
I remember that, yeah.
And so that puzzles me a little bit. Does that mean your semester final is going to be on both semesters?
Oh, I don't think so. I think just on what we've been doing this semester. But that is weird that this is on.
Yeah, you haven't been doing this semester. This was strictly last semester. This semester was all about volumes of solids, surface areas of solids, circles, all of it. But that's okay. I mean, you can't assume that he won't ask you a geometry problem from the first semester.
Right.
In other words, it really is going to be a final in geometry, not just final of the second semester material that you covered.
Exactly.
Because even this problem up here was last semester. Similar figures was last semester. This theorem right here was last semester. So is this one. So everything on this page is actually last semester stuff. But
just kind of
so clearly you do have to know last semester stuff also. How many more pages of material do you have? Just so we pace ourselves.
Yeah, I think we're going to have like 2 more, I believe. 2 or 3 more, but I'll schedule more sessions.
Okay.
Like Monday, Tuesday.
Yeah, we did your first page in a half an hour. We did this page in 45 minutes.
Right.
So you might want to take that into consideration if you have like 5 or 6 pages that need to be covered.
Exactly.
In terms of your scheduling.
Exactly.
Each page looks like it takes anywhere from a half an hour to 45 minutes to cover.
Right.
All right.
Awesome.
I'm going to let you go.
Sure.
And almost call it a week. I get a day off tomorrow. I actually have a day with no tutoring tomorrow.
Perfect.
Yeah.
Take that day to just relax.
I need it, yeah.
For sure.
I will talk to you. I believe we have one scheduled Sunday night. And
I think so.
I'll talk to you then.
That sounds good. Thank you, Mr. Cowan.
All right.